correct rule of thumb for wiring three-phase is brown, orange, yellow. The phase sequence is important because it ensures that motors and other devices connected to the system operate correctly. If the phase sequence is incorrect, it can cause equipment damage or malfunction. Here are the color codes for three-phase wiring in the United States. Phase A is brown. Phase B is orange. Phase C is yellow. Neutral is white. Ground is green or bare copper. Here are some tips. Firstly, always use a qualified electrician to perform electrical work. Secondly, label all wires clearly to avoid confusion. Thirdly, double-check the phase sequence before connecting any equipment. Understanding three-phase electrical systems requires knowledge of voltage, current, and phase relationships. In a balanced three-phase system, there are three voltage sources, each with the same magnitude but separated by 120 degrees in phase. The standard color coding helps to maintain the correct phase sequence, which is essential for the proper operation of three-phase motors and other equipment. When installing or maintaining three-phase systems, electricians must adhere to the National Electrical Code or NEC, which provides guidelines for safe wiring practices. The NEC specifies the acceptable wiring methods, conductor sizes, overcurrent protection, and grounding requirements for three-phase systems. For example, NEC Section 210.4 addresses branch circuits serving multiple loads, while NEC Section 215.12 covers feeder conductors. Proper grounding is crucial for safety in three-phase systems. The grounding system provides a lower impedance path for fault currents, which helps to trip over current protection devices and minimize the risk of electric shock. Grounding electrodes, such as ground rods or metal water pipes, must be properly sized and installed in accordance with NEC requirements. Overcurrent protection devices, such as circuit breakers and fuses, are essential for protecting three-phase circuits from overloads and short circuits. These devices must be selected based on the ampacity of the conductors they protect and the characteristics of the loads served. The interrupting rating of the overcurrent protection devices must also be sufficient to handle the available fault current at the point of installation. Voltage drop is another important consideration in three-phase systems. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. To minimize voltage drop, conductors must be properly sized based on the load current, conductor length, and allowable voltage drop percentage. The NEC provides tables and formulas for calculating voltage drop in conductors. When working with three-phase systems, it is essential to use appropriate test equipment to verify voltage levels, phase sequence, and ground impedance. Multimeters, phase rotation testers, and ground impedance testers are commonly used tools for troubleshooting and maintaining three-phase electrical systems. Electrical safety is paramount when working with three-phase systems. Always de-energize circuits before performing any work and use appropriate personal protective equipment such as insulated gloves, safety glasses, and arc flash-rated clothing. Follow lockout-tagout procedures to prevent accidental energization of circuits during maintenance or repair work. Three-phase motors are widely used in industrial and commercial applications. These motors are typically more efficient and have higher starting torque than single-phase motors. When installing or maintaining three-phase motors, it is important to ensure that the motor is properly sized for the load and that the wiring connections are correct. The motor nameplate provides information on the motor's voltage, current, horsepower, and other important parameters. Variable frequency drives or VFD are often used to control the speed and torque of three-phase motors. VFD can improve energy efficiency and provide precise control of motor operation. When installing or maintaining VFD, it is important to follow the manufacturer's instructions and to ensure that the VFD is properly grounded and shielded to prevent electromagnetic interference. Power quality is an important consideration in three-phase systems. Harmonics, voltage imbalances, and other power quality disturbances can cause equipment to malfunction or operate inefficiently. Harmonic filters, voltage regulators, and other power quality improvement devices can be used to mitigate these problems. Regular maintenance is essential for ensuring the reliability and safety of three-phase electrical systems. Maintenance activities should include inspecting wiring connections, testing overcurrent protection devices, and measuring ground impedance. A qualified electrician should perform these maintenance tasks to ensure that they are done safely and correctly. The brown, orange, and yellow color code for three-phase wiring is a standardized practice in the United States and other countries. While specific regulations may vary by region, the underlying principle of maintaining consistent phase identification remains crucial. This consistency allows electricians and technicians to readily identify and troubleshoot electrical systems, minimizing the risk of errors and ensuring safe operation. In addition to the primary conductors, the neutral and ground wires also have specific color designations. The neutral wire is typically white or gray, while the ground wire is green or bare copper. These color codes help to prevent accidental connections between different types of conductors, which could lead to short circuits or other electrical hazards. When working with older electrical systems, it is important to note that the color codes may not always be consistent with current standards. In these cases, it is essential to carefully trace and identify each conductor before performing any work. Using a multimeter or circuit tracer can help to identify the function of each wire and ensure that connections are made correctly. Proper labeling of wires is also essential for maintaining a safe and organized electrical system. Labels should clearly identify the function of each wire, such as phase A, phase B, phase C, neutral, or ground. Labels should be durable and resistant to fading or damage so that they remain legible over time. When making wiring connections in a three-phase system, it is important to use the correct type of connectors and to ensure that the connections are tight and secure. Loose connections can cause arcing, overheating, and other electrical problems. Using properly rated crimp connectors or terminal blocks can help to ensure reliable and safe wiring connections. Regular inspection of wiring connections is also important for identifying and correcting any potential problems before they lead to equipment failure or safety hazards. Look for signs of corrosion, loose wires, or damaged insulation, and take corrective action as needed. In addition to the color codes for wiring, there are also color codes for electrical components such as fuses, circuit breakers, and transformers. These color codes can help to identify the voltage rating, current rating, or other characteristics of the component. Consulting the manufacturer's documentation is important for understanding the specific color codes used for each component. When working with high-voltage three-phase systems, it is essential to take extra precautions to prevent electrical shock. High-voltage systems can be extremely dangerous, and even a small amount of current can be fatal. Always de-energize the circuit before performing any work, and use appropriate personal protective equipment such as insulated gloves, safety glasses, and arc flash-rated clothing. Follow lockout/tagout procedures to prevent accidental energization of circuits during maintenance or repair work. Regularly inspect electrical equipment for signs of damage or wear, and replace any components that are not in good condition. Damaged equipment can pose a safety hazard and may not function properly. Keep electrical equipment clean and free of dust, dirt, and other contaminants. These contaminants can interfere with the operation of the equipment and can also create a fire hazard. Ensure that electrical equipment is properly ventilated to prevent overheating. Overheating can damage the equipment and can also create a fire hazard. Follow the manufacturer's recommendations for ventilation requirements. Regularly test electrical equipment to ensure that it is functioning properly. Testing can help to identify potential problems before they lead to equipment failure or safety hazards. Keep accurate records of all electrical work performed, including wiring diagrams, test results, and maintenance records. These records can be helpful for troubleshooting problems and for ensuring that the electrical system is properly maintained. Staying up to date on the latest electrical codes and standards is important for ensuring that electrical work is performed safely and correctly. The NEC is updated every 3 years, so it is important to review the latest edition to stay informed of any changes. Consider attending continuing education courses or workshops to learn about new electrical technologies and best practices. Continuing education can help to improve your skills and knowledge and can also help you to maintain your electrical license or certification. The brown, orange, yellow color code is a fundamental aspect of three-phase electrical systems in the United States. Adhering to the standard, along with proper grounding, overcurrent protection, and regular maintenance, ensures the safe and reliable operation of electrical equipment in various industrial, commercial, and residential settings. Understanding the principles of three-phase power and following established electrical codes are essential for anyone working with these systems.